In order to solve rational expressions, rational equations, what we have to do is get rid of all of the x's in the denominators. Ideally, we'll get rid of all of the denominators because we can't solve if x is in the denominator. The way that we will get rid of the denominators is by finding the lowest common denominator and using it as a tool to eliminate all of the bottoms. Before we do that, our first step should always be to find out what x values we will not be able to have as final answers. In this case, we will set each denominator equal to 0 to find out what x can't equal. If I set the first denominator equal to 0, I'll find out that x can't equal 0. So that's the first one. For the second denominator, I can say 5x can't equal 0, which means if I divide both sides by 5, that again, x can't equal 0 divided by 5, which is 0. I already have that listed. So our first step is done. Now what we have to do is find out what the lowest common denominator is so we can use it as a tool. To find out what the lowest common denominator is, I'll take a look at the denominators we have to see if they have anything in common. This denominator has an x, this one also has an x, so x will be part of my lowest common denominator. Now the denominator on the right has a 5 that the x on the left doesn't have, so that 5 also has to be part of my lowest common denominator. The denominator all the way to the right is an invisible 1. It is missing both an x and a 5, but if I multiply it by the 5 and the x, I can turn it into the same denominator, so the lowest common denominator is just 5x. Now what we're going to do with this 5x is multiply it by every single term in our function. So I'm going to go ahead and write that work right here so I don't have to rewrite the entire equation. I'm going to take 5x and multiply it by the first term, the second term, and the last term. And when we multiply it by all three terms, what we're looking for is to cancel all of the denominators. So in the first term, 5x times 1 over x, I have an x in top and bottom that can cancel. And all I have left there is 5 times 1, which is 5. On the other side of my equal sign, my 5x is on top and bottom. All that's left is the number 6. And my last term is just plus 1 times 5x, which is just plus 5x. Now all I have to do is get x alone. X is to the first power, which means I'm not going to have to factor. I'm going to be able to solve right away, which means I'm going to start moving all of my numbers away from x. So 5x is going to be on the right, and on the left I'm going to have 5 minus 6, which is negative 1. Now all we have to do is get the 5 away from the x by dividing by 5, and my final answer is negative 1 over 5. Let's go ahead and take a look at another example. In this example, I won't know what my common denominators are until I see all of the factors they might have in common. So I'm going to have to take this denominator in the middle and factor it. I'm going to have to find the two things that multiply to 10, that add to negative 7. Those numbers are 2 and 5, and they're going to both have to be negative. I'm going to go ahead and just cross this out and write the factored form right here. So this is going to be r minus 2 and r minus 5. Now that I have this factored, I can go ahead and do my first two steps. My first step is to find out what r, in this case, is not allowed to equal. I'm going to set both of my denominators equal to 0, 1 by 1. Or all three of my denominators, rather, all of my factors. My first factor is r minus 2. If r minus 2 is 0, that means that the r value would be 2, so I'm not allowed to use the number 2. If r minus 5 is 0, the r value I'm not allowed to use would be 5, so that goes on my list over here. And then if I keep testing my fractions, I'm going to be repeating myself, so all of my denominators have been tested, and I'm not allowed to use the r value 2 or the r value 5. Up next, we want to find out what my lowest common denominator would be. So what we're going to do is find out what my equations have in common. The first thing we have in common is r minus 2. It's in both of these fractions, so r minus 2 is part of my common denominator. The next thing I have in common is r minus 5, so r minus 5 is in my lowest common denominator. The only other denominator that I have is the denominator with both of them, and they're both already in my lowest common denominator, which means I found all of the factors that I need. Now we're going to use that lowest common denominator as a tool. This time I will go ahead and show us multiplying all of our terms by the lowest common denominator. So I'm going to take r minus 2 and r minus 5 and multiply that by my first term, 1 over r minus 2. Then we have our plus sign, and I'm going to take r minus 2 times r minus 5 and multiply it by my next term, which is 1 over r minus 2 times r minus 5. Then we have our equal sign, and I'll take my lowest common denominator one more time, r minus 2 times r minus 5, and we'll multiply that by my last term, which is 6 over r minus 5. Now all of these lowest common denominators I've multiplied by have their own invisible denominator of 1, which means the factors I've multiplied by will only get multiplied to the numerator, and the invisible 1 will get multiplied by the denominator. And since they only get multiplied to the numerator, they are officially on top of all of these fractions, which means they can cancel out the denominators I have on bottom. So this r minus 2 can cancel this r minus 2, which means the only thing I have left in that term is the r minus 5 on top. Up next, I have r minus 2 that can cancel on top and bottom, and r minus 5 that can cancel on top and bottom. They all get replaced by the number 1, and if I take 1 and multiply it by 1 and divide it by 1, it just stays the number 1, so 1's all that's left. On the right side of my fraction, I have an r minus 5 on top and bottom that can cancel, and all I have left is 6 times r minus 2. Now we've gotten rid of all of our fractions, which means we're ready to solve. In order to start solving, I will have to distribute all of my terms so I can combine. In this side, r minus 5 plus 1, I'm going to combine those already, so that's going to be r minus 4. And on the right, I'll end up with 6r minus 12. Now all I have to do is get all of my numbers on one side and my r's on the other. It doesn't matter which way I move things. I'm going to go ahead and move my r's to the right because that's where they'll be positive, so I'll do minus r to both sides. And in the same motion, I'm going to move all my numbers to the left. So I'm going to add 12 to both sides. So on the left, I'll end up with no r's, but I'll end up with a positive 8. And on the right, I'll end up with 5 r's. All I have to do now is get the 5 away from the r by dividing, which means that my r value is going to be 8 divided by 5. The only r values that I found I couldn't use were 2 and 5. And this is a fraction that's neither of those numbers, so this is my final answer. Let's take a look at the next example of solving these rational equations. Again, my first step is to figure out what my variable can't equal. So in this case, n cannot equal. What I get, what I said, n plus 8 equal to 0. I get n is negative 8, so I'm not allowed to use that negative 8. Up next, if I take n plus 1 and set it equal to 0, I'm not allowed to use the negative 1. Those are the two numbers that I am not allowed to use. This denominator, invisible 1, if I set 1 equal to 0, it won't give me any values I can't use because 1 will never equal 0. Up next, we'll find our lowest common denominator. So we'll look at the denominators one at a time. This n plus 8 and the n plus 1 have nothing in common, which means the factors that they're missing are each other. N plus 8 times n plus 1. The only other denominator is the number 1. Technically, I can multiply that in here, but it wouldn't really change anything. So my lowest common denominator is just going to be the n plus 8 and the n plus 1. And we're going to multiply all three of the terms in my function by this lowest common denominator. So n plus 8 times n plus 1. We'll multiply that by our first term, which is n over n plus 8. Then our equal sign. Then we'll go ahead and take our n plus 8 times n plus 1 and multiply it by my next term, which is just the number 1. And all the way to the right, we'll take our n plus 8 times n plus 1 and multiply it by our last term, which is 6 over n plus 1. Now I'll look for common terms on top and bottom. N plus 8 and n plus 8 cancel. And so all that's left there will be the n and the n plus 1. On the other side of my equal sign, unfortunately in the next term nothing cancels, so I'll still have my n plus 8 and my n plus 1, but they're just getting multiplied by 1, so we can just write those by themselves. And all the way to the right, the n plus 1's cancel, and all I've got left there is 6 times n plus 8, which means we're ready to go to our distributing step. On the left, we could distribute the n inside my parentheses. We'll end up with n squared plus n. On the right, I am going to have to FOIL these together. I'm going to do that middle step and then simplify it down below. So n times n is n squared, n times 1 is n, 8 times n is 8n, and 8 times 1 is 8. I can combine these two terms together to get down here, n squared plus 9n plus 8. And then over here on the right, all we have to do is distribute my 6 inside the parentheses. So we get plus 6n plus 48. I'm bad at those. 8 times tables are not my strong suit. All right, so 8 times 6 is 48. Now all we have to do is start simplifying. I'm going to start by trying to move this n squared over here, and something interesting will happen, which is that they will completely cancel, which means my new equation only has n's to the first power, which means I'm not going to have to factor this to get my final answer. All I have to do is move all my n's to one side and all of my numbers to the other. So I'm going to go ahead and move this n this way, and I'm also going to take these two numbers here, this positive 8 and positive 48, and I'm going to subtract them to the other side. So minus 8 and minus 48. If I subtract 8 and 48, I'm going to end up subtracting 56, which will end up by itself on the left side of my equal sign. On the right, my n squareds have gone, and all I have is 9n plus 6n, which is 15n, and then I subtract n, I get 14n. All I have to do now is get n completely alone. I just divide by 14 on both sides. 56 is divisible by 14. It is actually the number 4, so we get n equals negative 4. Now the n values that I said I can't use are negative 8 and negative 1, which means this negative 4 is totally fine. That's my final answer. We have one last example of solving rational expressions. Let's go ahead and do that real fast. First and foremost, the m values that I'm not allowed to use. In order to find the m values I'm not allowed to use, I should be looking at my factored forms of all of my denominators, and these guys are not factored. M squared minus m has a GCF of m. So I'm going to go ahead and factor out an m. If I do that, I'll have m minus 1 left over. It's the same thing over here, m times m minus 1. Which means now I can set all of my factors equal to 0. First and foremost, if I set m equal to 0, m cannot be 0. Up next, I have to take m minus 1 and set that equal to 0, which means m cannot be 1. If I set any of my other factors equal to 0, all I'll be doing is repeating myself. Next up, we're looking for our lowest common denominator. To find the lowest common denominator, I combine my individual denominators and see what they already have in common. These two denominators both have an m in them. The denominator in the middle is missing the m minus 1, so the m minus 1 must be part of my common denominator too. Everything else matches, which means that's my lowest common denominator. Make sure that you look to see what they have in common before making your lowest common denominator, because you don't want to put too many variables in there. All right, now that I have my lowest common denominator, I will multiply it by every single term. M times n minus 1 times 1 over m times n minus 1. My next term will be m times n minus 1 times 1 over m. And last but not least, on the other side of my equal sign, m times n minus 1 times 5 over m times n minus 1. Once you've factored, keep using the factored form. It makes it easy to cancel. For example, this has an m and an m m minus 1 and an m minus 1, which means all that's left is the number 1. In the next term, the m's cancel, and the m minus 1 is left on top, being multiplied by 1. And on the right, my m and m minus 1 cancel, and all that's left is the number 5. This is a very nice problem because the 1's cancel each other out, and m equals 5. All done. The only numbers I couldn't use were 0 and 1, which means m equals fine is totally fine to have as a final answer. In the next video, we'll take a look at graphing some of these rational functions.